Hello, this is the second video in the laboratory orientation series. In the first video we gave a high-level overview of the environmental analysis industry and the role that private laboratories like Apple play in that industry. Now, why would anyone choose to send their samples to Apple as opposed to one of their competitors? And this issue boils down to the integrity and credibility of the laboratory, and that's connected to the quality of product that Apple provides their customers. If you think about where you'd take your car for service, there's a number of factors that you might take into consideration. Perhaps it's a brand you trust. Perhaps it's prior experience with that service technician or that company that leads you to trust their product and the service that you'll get. It may be a recommendation from a friend that you trust based on their prior experience. Perhaps you look at rating sites like Yelp or the Better Business Bureau. And you may need to check for certification or licensing. Are they an authorized service representative for your car's warranty? Perhaps it's licensing or certification in the state if you're getting a smog check that they are actually authorized to do it, those types of parameters. The same thing applies when we look at environmental labs, though the specifics may be a little different. First, in order to meet the EPA regulations, the laboratories need to be accredited and certified to do the specific type of testing. An example would be the National Environmental Laboratory Accreditation Program, but there's many others. There's ISO and a host of other types of accreditation programs. All of these will publish standards, and these standards are detailed lists of what a laboratory must do in order to receive accreditation. And the presumption is that these standards, as written, and if a laboratory fulfills all of these, that you can trust that they're providing a quality product to their customers. Now, a laboratory will typically write their policies and procedures to meet these accreditation standards, but then they need to prove it in some sense. It isn't good enough that they think they meet it, they need to check. And they'll pay for auditors from these accrediting agencies to come out and do a site visit. At these site visits, 2 to 5 auditors will show up and stay typically for 1 to 3 days, something in that range. During that visit, their primary task is to review laboratory policies and procedures. First, to check that those policies and procedures are sufficient to meet the accreditation standards. And second, to check what the laboratory is doing, talking with analysts, talking with management, spot checking case files, looking at essentially systems and processes to ensure that not only do the policies and procedures meet accreditation standards, but the laboratory is in fact following their written policies and procedures. And if all this works out, there's some mechanism by which the laboratory can report that they're certified. Maybe it's a certification number, maybe it's a printed certificate, but some way for them to communicate to clients that they've received this accreditation with the expectation that an accredited laboratory should be trustworthy. But it's just as important. Essentially all Apple's competitors are accredited. The thing that sets them apart is the brands that they've developed over 30 years. This is based on their customer experiences working with the laboratory and the reliability and consistency of their results. These results, in order to build this brand and maintain the Apple brand, need to be accurate and reliable. They need to be delivered to clients promptly, and they need to be kept confidential. Apple will keep records in case of a court order, but the privilege of disclosing and publishing these results to customers and the general public, it lies with the client. They have the full context of what the results mean. Apple is providing them a service, and so it's critical that we keep client information confidential. Once these sort of 4 top are in place, Apple is providing a quality service to the clients, then cost becomes a factor. It's always possible to test things cheaper, but the key is to provide that quality result and then do it at a reasonable and competitive rate. The system by which Apple ensures that they're providing quality results is the Quality Assurance Program, and you will be required to read the Quality Assurance Manual as part of this training. Quality assurance is an overall system for ensuring a desired level of quality in the development, production, or delivery of products and services. In Apple's case, this is ensuring that when we issue a result for, say, the amount of lead in a water sample, that result is trustworthy and is of high quality. This process is required of nearly every accreditation program and is critical to Apple's continued success in the business. Quality assurance broadly will include written policies and procedures using validated methods, quality control samples that are run to ensure that parameters of the instruments are similar to or consistent with the environment under which the validation was performed, analyst and employee training and performance evaluation at a technical level, the review and reports, and we'll talk a little bit about the process that samples go through in the reporting, and then retention and records and data for review by accrediting bodies or clients. The written policies and procedures are critically important. There's a huge number of them, and it's easy to get lost in them. These are detailed procedures for the analysis in this case, but also for quality control. But in this case, the analysis, they're detailed and they need to be followed specifically. In this example from a GC method, you'll see that it outlines which instruments this method applies to, what columns need to be installed in the instrument, which detectors, etc. There's little details like injection vials with crimp tops, and these are the little 2 milliliter vials that are routinely used with GC. When we talk about following and complying with procedures, these need to be done strictly. In other words, if VWR or Fisher were out of crimp top vials and Apple got in a shipment of screw top vials, that would not comply with this method. Typically, the methods are written to allow some variability when appropriate, but these procedures are detailed and they're followed strictly to ensure that the method validation applies. As part of method development, before a method is used in testing, it's validated. And this is essentially a process by which rigorous testing is done to ensure that the method is doing what it's supposed to, that it's suitable for the analysis of the types of samples it's handling. This would typically involve testing of the accuracy of methods by testing known standards. It would involve replicate testing to establish the precision of testing or how much variability there is in the quantitative results. You would establish a working range of how low a sample can be accurately quantified and how high a sample can be accurately quantified before saturating detectors. And your samples that you're testing, the levels you expect to see in samples, should be within that working range. You'd look at sensitivity. Is it sufficiently sensitive to issue results on the types of samples? So consider thallium, for example, that has a very low maximum contaminant level under EPA or hazardous level, and it's difficult to detect in those part per billion concentrations. Is the method sufficiently sensitive that it will be able to see thallium if it is a hazard to human health? Is it selective? Does the method give a positive result for that compound, and what's the likelihood of a false positive or an interferent giving a result that looks like a positive for the chemical? How rugged is it? What types of tolerance does it have for different types of samples? Is it only good for relatively clean water? Will it also work for salt water? Will it work for the types of samples that you're expect to get in, and what's the likelihood of the method going down? And this goes on. This method validation process is extremely expensive. In some cases it happens at each laboratory. In other cases, the EPA will conduct a rigorous method validation, and then laboratories only need to do a moderate amount of testing to ensure that their instrument and their laboratory is capable of meeting and achieving the same results that were established in the method validation. So that's a step down. If you validated the method on instrument A and you wanted to bring instrument B online, you would also need to do a more compact verification or a check that it still complies. This might be a method detection limit study on that instrument, but some set of standards through which you establish that I'm seeing the same performance on both instruments, and therefore the method validation that was done initially applies to the work I'm doing on this new instrument. And then it goes down another step, that method validation might have been done in 2005, and how do we know that it still applies? As part of that validation, a set of quality control samples are written into the procedure. These quality control samples may include blanks, spikes of standards, replicate measurements, matrix checks where standards is added to a matrix to see that it's not affecting the results. And these quality control samples and the acceptance criteria that are established for them are there to say that all that testing that we did in 2005 still applies. It still works because our quality control samples still meet those expectations. If they didn't, you need to go back and do more testing. Maybe it's just redo the calibration curve. But if you're seeing a degradation in resolution or different resolution, you need to go back to that validation and see how it's impacting all those parameters and ensure that this test is performing reliably and accurately and that the results from the test can be trusted. Now, even if I have a great testing method up and going, that doesn't mean that anyone in the laboratory can do it. The laboratories need to have, as part of their quality assurance program, training and performance evaluation for analysts and collectively in place. Any analyst or group that's conducting testing before they're allowed to begin analysis will need to provide a demonstration of capability. And this is essentially analyzing some known sample and showing that you can get a result that matches the known concentration. If you can't, something's wrong and needs to be fixed. These demonstrations of capabilities are performed periodically by most laboratories and certainly on startup of any new analyst. The proficiency testing is a process by which a sample that the laboratory does not know the concentration comes in for analysis. The laboratory then conducts their analysis and will submit to the proficiency testing company what they say the result is, what their testing shows. And that is then checked by the proficiency testing company to establish that yes, this laboratory can issue accurate results. So that's a check that can be conducted again for individuals or the laboratory as a group. There's another type of proficiency sample which comes up called a blind proficiency sample, and this is a sample which comes in as an unknown, as just a normal water sample mixed in typically with required testing. And the analyst or the laboratory as a whole does not even know that it's a proficiency sample. They'll then issue their result, and the company doing the blind proficiency testing can either keep that private or let the laboratory know, hey, we did a blind proficiency test and you guys were within 10% of the target value as required. This can be a very valuable process for clients to ensure that the laboratory results are accurate. But again, for these proficiency test samples, the presumption is that if the laboratory accurately reports the level of these known samples, then you can trust that they're accurately reporting all of the samples. There's a process in place to catch human mistakes, and human mistakes are just a part of any of these companies' testing. People make mistakes. The laboratory has quality assurance procedures in place to catch that. So when samples come in, they're entered into the evidence system and an analysis request form is generated. They're assigned to analysts. As an analyst, you'll receive that sample and you'll test your samples and upload your results, and you'll do a first review of those results, of going back through the results and checking as you prepare your case narrative and your quality control review sheet that in fact everything has been done. And perhaps when you set up your sequence you forgot to run a blank that was required. This is the first chance to catch that mistake. Once that case packet is assembled with the case narrative and the peer review sheet, it goes to either a peer or supervisor for a second review. And their job here is to go back through everything and make sure that there aren't any silly mistakes, that some number hasn't been entered wrong, that there isn't a flag on a result that should have been put in that didn't end up in the system. Maybe the person forgot, maybe they didn't hit save. Make sure that everything's in order. And then there's a final review. When the signature on the report certification goes out, there's an administrative final review. And this means at a minimum, any report issued by Apple should be carefully reviewed by 3 people. And ideally, if one person makes a mistake, the other 2 catch it. And that's the process that's in place to ensure that reported results are reliable and accurate. These are pretty standard, but again, if a laboratory follows and establishes these quality assurance processes and does them in good faith, then there should be an expectation that the results that the laboratory is generating is trustworthy. Apple has been doing this for 30 years and has gone to great lengths to ensure that this is the case, and as a result has built up a national reputation as a quality laboratory that can be trusted to do testing in the environmental analysis, quality monitoring, etc. The next step in this is how do we ensure that analysts are following these procedures and doing these procedures in good faith?